Another way on how to write the tangent line at x equals -1 given this function is here, and this is, I hope, a simplified version than the first. So remember, if we will recall, we found the slope, right? We have the f prime of x, which is 22, and we have the f of x, which is 13. Remember that another notation of derivative is slope. That gives the slope as well. So we already have a slope, which is m. And the second one, when we substituted it to the given function, remember, we have a point already, the xy. And what is that? We have an xy, so therefore we have a 113. Going back, y minus y sub 1 is equal to m times x minus x sub 1. This is, a form using a point slope form to write an equation of a line. And on top here, we have a slope and a point. So therefore, we need to use this. Okay? This is the form that accommodates a slope and a point. So let's plug in. Y minus, so this is your y. You have a 13. You have a 13 here. Is equal to slope here, which is 22. X, so this is a plus 1, right? Why plus 1? Because in here, take note, in here, it's -1. So if you put back this into its original form, it is plus 1. When you solve this, it will give you a -1. So putting that in the form, it will become a plus 1. I hope that's clear. So now what we do is isolate y. We transpose 13, so we'll get 13 plus 22 x plus 1. Okay? Now, let's go to the next page. Copying y is equal to 13 plus 22 times x plus 1. We can now have the equation of a line. Equation of the tangent line specifically at x equals -1. 13 plus, so we distribute. Be very careful with this, because remember, you have to give it to this too. 22x plus 22. Y is equal to, combine like terms. What like terms do we have here? We have a 13 and a 22. So we have 22x plus 35. And this is the equation of the tangent line needed at x equals -1. I hope you find this easier than the first.